So first, will always be. Find, I'm going to say always. If you can do this, you should do this. Find a greatest common factor and pull it out. So find a greatest common factor, GCF, and pull it out. But just because you do this first step doesn't mean you're done. If you do this first step, you still have to go on and say, okay, do I have 3 terms? If so, can I do this? If I have 2 terms, can I do this? 4 terms, can I do this? So just because you do one step doesn't mean you're done. It's just saying that's the first thing you do. Go on. All right, then we have our different number of terms. If you have 3 terms, this is the more traditional that you've practiced probably over and over and over again. I'm going to kind of shorthand my steps. You need to multiply A times C to start. In step 2, you will separate the B. And in step 3, you will factor by grouping. Okay, let's go ahead and go over to the 4, and then I'll do some examples of these 3 that I've done so far. So on the 4 term, this is actually, while it seems like 4 should be harder, it's actually going to be much easier. You're going to skip the first 2 steps and just factor by grouping. Okay, so let's go over to the back. Okay, now we're left, we've done the GCF part. If it has a GCF, you do it, but you still may have to do the 3 term, you still may have to do the 4 term. You still may have to do the 2 term. This is the one that we have left. So if you look and there are 2 terms, it may not factor. That's what happened on example 1. But it may factor still. It may factor if these 2 terms contain squares. It may factor if these 2 terms contain cubes. So, of course, squares are like numbers. 1 is a square. 4 is a perfect square. 9 is a perfect square. 16, 25, 36, so forth. Perfect cubes, I realize that y'all may not be as familiar. I'd probably expect you to know for now up into about 5 cubed. Past that, we'll get there, okay? Okay, for squares. For squares, you have a thing called difference of squares. And there are certainly a lot of examples on the back, but I just want to write some examples down here, and then we'll go to the back after I do both of these. So, difference of squares, the one that almost everybody thinks of automatically is x squared minus 9. So, you identify this because x squared is a perfect square. The square root of x squared is x. The square root of 9 is 3. And they are separated by a difference, a minus sign. So, I said the square root of x squared is x, square root of 9 is 3. Separate once with a plus, once with a minus. Of course, they can get more complicated. You can have a number in front of this and a higher number. Let's say 121. So, do you recognize the 121? 11. Very nice. So the square root of 4x squared is 2x, and then I have an 11. So 2x plus 11 and 2x minus 11. You want to do a little bit harder? One more. Let's do, okay, 2x squared minus 50b to the fourth. So, at first, you're looking at this and you're saying, that's not a perfect square, that's not a perfect square. But what's the problem with that? GCF first. It's really easy to forget the GCF, but don't do it because it can mess everything up. So this contains a 2, this contains a 2. So first I'm going to say this is 2x squared minus 25b to the fourth. Now I'm saying, okay, square root of x squared is x. Square root of 25b to the fourth is 5b squared. So the 2 is still there. X plus 5b squared, x minus 5b squared. Okay, but that's as hard as they're going to get for difference of squares. It didn't move. Okay, let's do the cubes. The cubes for most of you is probably going to be new. I kind of think we did it for like half a day in Algebra 2, but I don't even see the point of that. So, for the cubes, you have a sum and difference of cubes. So, just by me saying that, it is already different than the squares. Because for these squares, you only have a difference of squares. Let's write that down because a lot of people see the squares and they don't think about if it's a plus or a minus. There is no sum of squares. If you see two squares but they're separated by a plus, you cannot do anything. So there is no sum of squares. But there is both sum and difference of cubes. So, let's do the sum of cubes. First, the sum of cubes is going to be a cubed plus b cubed. For now, I want you to write a parenthesis that's only going to contain two things, a parenthesis that's going to contain three. So a little small and a little bit bigger. This is the order that you need to remember. First of all, what's the cube root of a cubed? Just a. What's the cube root of b cubed? So that's kind of your first step, just like it is for the difference of squares. You square root each of them, and that's the number that you're thinking of. So this a is going to go here. So this is a, this is b. This is that same a, but you're going to have to square it. This is a times b. I am leaving a space there for plus or minus sign. I'm going to explain in a minute. This is a times b in the center, and this is b squared. Is that better?
So your second parenthesis will always be that?
Yes.
You just have to change it plus or minuses?
Yes. And for the plus or the minus, I actually learned this year. There's an acronym. They call it SOAP. Put an S, put an S dot O dot AP no dot. SOAP stands for same sign. S is same. O is opposite sign. AP is always positive. So that goes in the order. Notice that your sign here is plus. So it has the same sign plus. then it has the opposite sign, that's minus. This one will always be positive. So that's plus, minus, plus. Yeah, I had to memorize these. It's not fun. Nobody told me soap. Okay, let's do the difference. The difference is basically the same. You're going to have a cubed minus b cubed now. But that order of a squared, ab, b squared stays. So you have a here, you have b here, then you have a squared here, you have a times b, then you have b squared. And then SOAP will tell us plus or minus. So same sign, this is a minus, opposite sign, minus, plus, plus. No, it was actually Mr. TM.
Really?
Mm-hmm. Actually, I say that. I think it was Mr. TM's student. He was like, oh, just think of soap. And we were like, what are you talking about? Okay, 1, 2, and 3. We're going to come up to that top half in just a little bit. So just go to example. Let's do 1 first. So in 1, before you start, no matter what, you look for a greatest common factor. So between 2x to the 4th and negative 4x cubed, what do they have in common? 2x to the 3rd. They both are divisible by 2. They both contain x to the 3rd power. And so now you're kind of, in your head, imagining the opposite of distribution, or kind of distribution. You're just saying 2x cubed times what gets you 2x to the 4th. So what do you need to still multiply that by? X. 2x cubed times what here gets you minus 4x cubed. Minus 2. Okay? Again, just because you've done one thing doesn't mean you're done. But if you look inside the parentheses, there's an exponent of 1 here, or not an exponent if you want to say that. You certainly will not be able to factor without an exponent of x. So this is going to be the final answer. Sometimes it is just one step. Sometimes it's not going to be.
Isn't it like you can change it to like 2x cubed plus 1 times x minus 2?
Okay, let's do example 2. I'm going to have to enlarge this because it takes quite a bit more space. So y'all change this to a minus 12, right? Okay. All right, so 4x squared plus 8x minus 12. What do they have in common? 4. If you are thinking 2, technically, yes, they do have 2 in common, but that is not the greatest common factor. That is a common factor, but not the greatest. So we pull out the greatest, which is a 4. Open, x squared plus 4 times 2x, 4 times minus 3. I don't really love this being the example that they have in here because I would rather them show the example of having a coefficient here. So I'll do another one on y'all's homework. But we'll start here. Okay, so if you look inside of your parentheses, this is a 1, 2, 3 term. For the 3 term, we said multiply a times c. ax squared plus bx plus c. So I'm multiplying 1 times negative 3. And that's negative 3. This is just kind of side work. And obviously for negative 3, it's not that hard. But when you get bigger numbers, you might want to do some side work. The only numbers that multiply to negative 3 are 1 and 3. But now I'm concerned with adding 1 and 3, somehow making it equal to 2. So how can 1 and 3 add to 2? Which one's negative? Negative 1 is and positive 3. And just do a quick check. Negative 1 times positive 3, is that negative 3? And negative 1 plus 3, is that positive 2? Okay, so we are going to separate the b. At this point, this 4 gets people confused because they're like, what do I do with this 4? Nothing. If it helps you, go ahead and come down here and write your answer box and just write the 4. And from now on, just kind of ignore it. It's not going to change it. As long as you include it in the answer, that's fine. I think it's easier if you just kind of ignore it from your brain. So, okay. We're on step 2. Step 2 said separate the b. So rather than writing positive 2x, I'm going to write plus 3x minus 1x. That's what separate the b means. But I'm not asked to change the a or the c. So I still have the x squared and I still have minus 3. Notice here you could have wrote minus 1x plus 3x. I wanted to do this one to show you the harder version of the two. So that's what I'm doing. Okay, step 3 said factor by grouping. Factor by grouping says group the first two, group the second two. And now you're kind of, what's common among x squared plus 3x? X, open, what's left in sign? X plus 3. And what's common in the second group? Negative 1. This is why I wanted to show you this example, is if your first term is negative, you must pull out negative. And even though I'm not really pulling out a number, you do need to think about the 1 being a placeholder there so that you know the binomial. So, times x, negative 1 times positive 3. Okay, if you remember from Algebra 2, we like factor by grouping because this is your checking point. X plus 3 matches x plus 3. That says I've done everything right so far. So I can write my answer. One of the answers is x plus 3, or one of the groups is x plus 3. The other one is the leftover x minus 1. And if you would like to take the time to FOIL and do all that, you can do that and check. If you have the time on the test, I think it's a good idea, especially on the ones that you're unsure of. There's no reason why that 4 is orange. It should be there. Okay, let's go to example 3, and y'all change this to a negative 36. Again, it's just a typo. You would never be expected to know to do that. I'm just going to rewrite it again because I don't like to factor by grouping with the typed print. So if it doesn't bother you, I don't care. I just don't like it. Okay, so I'm looking at this problem. I say 2x cubed, 8x squared, plus 9x minus 36. Do all 4 of these have anything in common I could pull out? No. So I start just factor by grouping. This is why it's so much easier. You simply start just by putting in your parentheses, parentheses. Again, 4 seems like it should be harder, but it's really not. You just start with it. So what's common in my first group?
2x cubed, or 2x squared.
2x squared. Open. What's left in?
x.
Minus?
4.
4. Very nice. What's common in my second group?
9.
Positive 9. You do need to write the positive 9 so that you know what's in the group is 2x plus 9. And then I have x minus 4. My checking, this matches this. So I've done everything good so far. And now you just write it. It doesn't matter which part you write first. So if I write 2x squared plus 9 times x minus 4. If you write x minus 4 times 2x squared plus 9, that's just as fine. Any questions?
We did this first semester, right?
Yes. And especially what we're about to go and do, hopefully you recognize from trig really well. Okay, so in 4, is there a greatest common factor before you start? No. Okay, so no greatest common factor. So, is this an example of difference of squares?
No. Or
Yes. What is the square root of 4x squared? And the square root of 81, a to the 4th. 9a squared. Separate once with a plus, once with a minus. Difference of squares is the best thing because it's super easy. As long as you can identify it. Yes. Okay. I want to do the harder one first. Seems like I'd want to do the easier one first, but I don't because it seems like it's super easy but then sometimes it gets harder. So, oh, wait, I'm sorry to jump around, but I want to go up to the top first. There's a reason why I'm doing this up at the top. In about 2.5, maybe 3 weeks, y'all are going to have a 90-second quiz, and it covers all of these plus more. I just wanted to get us started, so these are the ones that I included today. It's 90 seconds. It has about 20 questions on it, and the point is these need to be memorized. You don't need to be thinking 3 to the 4th. That's 3 times 3 times 3 times 3. That needs to be quick, okay? So let's go through these. I know a lot of them probably aren't memorized right now. So 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. That's probably how far you have it memorized. But if you have this, then you're just doing times 2. 8 times 2 is 16. Times 2 is 32. Times 2 is 64. Of course, with 2's, timesing by 2 is not that bad. With 3's, 3 to the first is 3. 3 squared is 9. 3 cubed is 27. Hopefully you have to there memorized. 81. That is one that we're actually going to see kind of a lot of. So I would definitely memorize that one. All right, 4 to the first is 4. 4 squared is 16. 64. 256. I will say 90 seconds, while it doesn't seem very long, 90 seconds is long enough for you to go, what's 64 times 4, and do it really quickly. You have to be quick at it, don't get me wrong, but 90 seconds is long enough for you to do that maybe 1, maybe 2 times, depending on how quick you are. Okay, let's do 5s. 5 to the first is 5. 5 to the second is 25. 125. 625. Okay, you also will have to, that's something that's not on here, is 25 squared. The reason why I want to talk about 25 squared is because it's 625. Let's think about why that is. 5 to the 4th power is 5 squared times 5 squared. Y'all agree with that? But 5 squared is 25. So now I'm doing 25 times 25, which is 25 squared, which is 625. It's all a circle, right? So understanding the logic between this, like ones that are similar to each other, that's going to be helpful. For that same reason, that's why 9 squared equals 81, because 3 to the 4th is 3 squared times 3 squared, which is 9 times 9, which is 9 squared. It's pretty neat, right? I know. Y'all are just, don't admit it, but it's awesome. All right, 6 squared is 36, 49. I think most of these y'all should have memorized. 64, 81, 100, and 121. We are going to go up to the 7th power on quite a few, so. But this is a good start. Don't worry about it yet. Before the quiz, I will give y'all like a practice quiz, and I will give you as many as you want, and I'll say go home, set your microwave for 90-second timer, and see how many. Oh, yeah. Okay, Miss Scott, I don't want to say that. Never mind. I'm recording. I'll tell y'all later. It's just a fun thing. All right. Example 5. So the reason why I wanted to talk about those cubes before I started is because maybe you didn't recognize 8, but 8 is a perfect cube. 27 is also a perfect cube. So let's just identify what the cube roots of these are. What is the cube root of 8a cubed? 2a. And what is the cube root of 27? b to the 6th. 3b squared. What you're thinking about is if I cube this, 3 cubed is 27. B squared cubed is how I'm going to get b to the 6th. So these are the two numbers that we're going to use. Draw your first parenthesis. That's the little one. Draw a much bigger one. The first parenthesis is pretty easy. It's just this and this. I'm not going to worry about the sign because I'm just going to do that later, okay? So I'm going to do 2a and 3b squared. Now, the second parenthesis is a little bit harder because it's something squared, they multiply, the other thing squared. So, 2a is first. You're going to square 2a. What is 2a squared? Good. Make sure you are squaring both the 2 and the a. What goes in this middle term? Are these two things multiplied? So 2 times 3 is 6a times b squared. 6ab squared. And then what goes in this last is the 3b squared squared, which is 9b to the 4th. Okay? And then from here we fill in plus or minus. This is originally a minus, so same sign, opposite sign, always positive.
She goes like a song, like the square. They used to in the 7th grade.
All right, let's do it one more time. What's the cube root of x cubed? And cube root of 1 is 1. So we have a small parenthesis and a much larger parenthesis. What goes here is just the x and the 1. What goes here is the first squared, x squared. They multiply. X times 1 is just x, and then square 1, which is still 1. Plus, minus, plus. All right, last little thing is down at the bottom, if you wanted to check, you could just multiply this. So you could do x plus 1 times x squared minus x plus 1. So x times x squared is x cubed minus x squared plus x plus 1x squared minus x plus 1. So when you do that, you see negative x squared plus x squared cancels. Positive x minus x cancels. So x cubed plus 1, which is in fact, well, if you could see it, what you're supposed to get. Okay?